Semua boleh nampak
Nampak dah tu?
Okay, so basically why do we need to calculate the sample size? So it's enough sample that can represent the population of the study. Okay, sample size too small may produce inconclusive result and also considered unethical by exposing human subject or animals. And as well, sample size too large will waste resources lah, such as you tak perlu terlalu banyak pun tak perlu. So you just need very optimal sample size in order to achieve reliable result from the study lah. So as usual, you have to come up with your objective, and from the objective you need to calculate the sample size. So what the sample size, what is the minimum sample size that need for your study lah. So basically, what do we need to calculate the sample size? Basically, you should have the objective lah. What is your objective? Sampling method known, precision required, as well the statistical test that you want to use based on the specific objective. You should so know lah. All right, and as well you need to set the power. Usually by 80% lah, the power 0.8, and with the confidence level 95% alpha equal to 0.05 lah. And as well for the survey, you may anticipate it for non-response rate lah, 10% to 20% lah. Okay. So basically for the sample size calculation, for estimation usually for the descriptive study, so you might use single mean and single proportion. So what is single mean? Okay, your single mean here is that your objective is like to estimate the mean of an outcome of interest in a population from data from the sample. Okay, so your interest now is to maybe mean. Okay, so to get the descriptive lah based on your objective. Okay, for the second one is the single proportion. So single proportion here is that to estimate the proportion or ada any question ke? Tak ada. Okay. Okay. So basically the single proportion here is that to estimate the proportion or percentage of an outcome of interest in a population. Basically, any prevalence, any percentage. So basically, whenever you know that, so your interest in your specific objective is the percentage. So with that objective, now you know that you can use the single proportion. So ideally, you need to know what is your interest based on your objective itself. Okay. So these are some of the example for the sample size calculation for single mean. So these are the values that is qualified or 2 squared standard deviation squared divided by the precision squared. All right. So basically by default, whenever you use the 0.05 with the 95% confidence interval, we'll use the 1.96 lah. Okay, with the standard deviation that you will need find from the previous study as well. You need to come out with your precision. So later we go for how you to calculate precision based on the previous study. Okay. Now let's say I would like to my objective one to determine the mean DMFT of 16 years old in Pahang. So now if we plan 95% alpha equal to 0.05 with the standard deviation is estimated as 4.3. So with the sample size n equal to 250, right? So now you may enter the value Z alpha, which is the 1.96 times with the standard deviation. Okay, so this is where you find from your previous article or previous study lah, as well with the sample, total sample. So now it's with the scale to 150, and then after you compute, you come out, and then the precision here is the 0.533. Okay, now after you got the precision, okay, now if you want to use the same precision as well can, but now let's say if you want to increase the precision to your study, I mean, you just make it much more lower the precision compared to the previous study lah. For example, here maybe 0.53. Okay, so you just reduce to 0.50. Okay, and so here, for example, I'll just put it back to this formula, 1.96 times with the standard deviation square with the precision that you estimated as a zero point 0.5 lah, from the previous study is 0.5 something. Now I'm going to reduce that one to 0.5. So now my sample size that I need is around 285 lah. Okay. So that will be for the single mean formula lah. So basically these are the idea whenever you decrease the precision, the sample size will be much more higher lah. All right. So now these are the example how you're going to write or to put in your proposal. For example, these are the some of the you may follow lah, either as this is, or you might come out with your own. At least you have all the information lah. So, for example, the power of the study. If you have the power of study is at the moment here, this we already not calculated because we consider for the descriptive study lah. Okay, but again, this for this one, at least you need to know the precision as well the confidence interval as well lah. Okay, so this one for the single mean formula. Okay. Next one here, okay. So this one for the sample size calculation for a single proportion. So this is a formula where the z alpha square, alpha 2 square, with the times with the p1 minus p. So p is the expected outcome lah, from the previous study, and divide by the precision square lah. Okay. This will be for the single proportion. Now let have one example here. To determine the prevalence of smoking among 16 years old school children in Pahang. Okay, so now again same as well. You need to come out calculate the precision using the precision formula. Okay, basically you just insert back this say alpha over 2 square with the p minus 1 over p. So you need divide by the 280 lah. Okay, so 0.4 where you get from the previous study with the sample size, and now the precision that you got here is that 0.0574. Now let's say I want to repeat back to my study, for example. At least I need this value lah, 0.0574. But let's say if you think that you can increase the sample, I mean the precision, I mean to decrease the precision, now it will automatically will increase your sample size lah. So basically here you just come out with your sample as well with the precision. Okay, so 1.96 square, 0.4, 1 minus 0.4 divided by the precision square lah. So this is where now you specify your precision to 0.05. Now you just round off the value to 369 lah. So at least you need 369 for the to achieve this objective lah. Okay, so that will be for the for the proportion. As well, we know that's a single proportion formula lah. So as you know now, as you can see here, the lowest the precision here, the sample size also will increase as well lah. Okay. So these are the how you're going to report lah in your proposal lah. Okay. So that will be basically the Z value is conventional by 95 confidence interval. Z will be 1.96. Okay. Standard deviation or prevalence is estimated by the pilot or by the literature or previous study lah. So how to decide? So generally, the smaller the precision is better. However, the research commonly have limited. So it might depend on previous. In case of very few first study or maybe is I mean previous study, there is no. I mean very new. So a relatively wide set might still be accepted lah. So, however, if previous study have been reported a certain wide of this confident interval in the study, we should come up with a better narrow if want to repeat the study lah. Okay, so that will be for the single proportion and single formula. Is there any question you want to ask? Okay, not okay? Kau mengantuk dah semua.
Okay, okay.
Okay, so next. Okay, so next, okay, so this will be a sample size calculation for two mean and two proportion lah. So basically, previously we can calculate by, for previously for the single mean or single proportion, for the descriptive lah. Now, let's say if you have two group, for example, let's say, in this example, let's say I want to compare the mean DMFT of 16 years old school children between urban and rural area in Pahang. So basically, I want to compare between these two area, urban and rural. So first, you need to have the mean and standard deviation lah, as well with the sample size as well. Okay. So from there, you can just come out as well with the pool of standard deviation. Okay, so this will be the pool of the standard deviation. You just need to enter into this formula until you get the 1.29 lah. So basically, these are the value that you need to enter into the software lah later, so that you can estimate the sample size that you need. Okay, for example here, so we will select the t-test here. So what do you want to know? Sample size. Okay, paired or independent. So now this is independent here. So alpha equal to 0.05 with the power of study 0.8. So this is the mean difference between the two groups. So you just need to minus between urban and rural. So you compute the differences and then you just need to enter to the mean differences here. And this is the pool standard deviation that you have calculated, where with the m equal to 1 is meaning here you want to have the equal equal sample between both group lah. Okay, for example here, I will calculate all the value that I already insert, and then I click the calculate, so I will get the sample size 192. It's meaning here that each group that you need 192. So group A and group B lah. So with the total 384 lah. Okay, so for the total, okay, so that will be for the two means. For the prevalence as well, same. You should know as well the prevalence of the urban and rural. Let's say if you want to compare the prevalence of smoking among 16 years old between urban and rural area in Pahang. So now you need to have the value of prevalence from the previous study. So with the previous study with alpha equal to 0.05 and power of study 0.8. So these are the prevalence with the m equal to 1 if you think that you want to have the same sample across the two groups lah. So for the two proportion, you need to select the dichotomous here. Okay, you can see there is a dichotomous. So you need to calculate select the dichotomous. So and then what do you want to know? Click the sample size. You select the sample size with the independent, prospective, two proportion, and you select the Fisher exact test here. So you just insert the alpha equal to 0.05 with the power of 0.8. Okay, these are the prevalence 0.12 and as well with the 0.16 with the m equal to 1 where you want to equal across two groups lah. So at least now you need per group 1229 lah for the urban and rural 1229 lah. Okay, so that will be for the two proportion. Okay, so now next we go for the sample size calculation using G power lah. So before this, there's a based on one by descriptive, one as well for the two groups lah. So basically for the sample size calculation, okay, using G power, okay. So basically the G power is designed for general power analysis program for statistically test commonly used in research. So it can be installed in Windows, MX, or so it's cover many different statistical tests lah. So it's free software and can be accessed through a website. Okay. GPower can also be used to compute the effect size and to display graphically the result of power analysis lah. So basically, in order to get an idea, for example, based on your first objective, for example, you should know, let's say, if your first objective is this descriptive, you can use the either single mean or single proportion. Now, let's say you already identified for the first objective. Now you want to see there any difference between two groups, for example. So you need to know what kind of statistical test you need to use for the specific objective lah. For example, here I have put some of the few example here so that you can have an idea lah. Okay. So basically for the one sample t-test now, your interest here only one sample lah. And here you want to compare with the previous study that already been reported, the uh, previous, let's say if you're going to find out with the mean, for example, let's say if you want to compare the current mean of the from the current study, so you need to want to compare with the previous study as well. You need to take the mean lah from the previous study. So that's the one sample lah. So for the independent test now, this is what the where you want to test, for example, between the two groups now. For example, I want to see the different test score, for example, between the male and female, for example. Okay, so now you should know what is your dependent, what is your independent. So from there, you can decide the independent one sample or paired t-test lah. So for paired t-test, you want to see any different or not before and after lah. So this one is the dependent variables where, for example, I would like to test the test score, for example, before and workshop and after the workshop, for example, but I need to with the same patient lah. Okay, participant. Okay, for the 1 week ANOVA, okay, your dependent is numericals. So your independent variables here now is the categorical where there is a 3 level. For example, let's say for example, you want to compare knowledge, for example, between the year of the study, for example. Example, you have year 1, year 2, year 3, year 4, year 5, for example. So that would be 1 week on a one. Usually for 1 week on a one, more than 2 categorical variables. And for the chi-square test here is that for 2 categorical variables. So let's say if you say that you want to see any association, for example, I would like to see association, for example, dental caries status with gender, for example. So my first variable here is dental caries status. For example, caries present or caries absent, for example. Now the second one, second variable is the gender, male and female. So I want to find out is there any association or not between these two variables. So now you can use the either chi-square or Fisher Z test lah. Okay, so that is the general idea. So I will just show you one of the examples so that you get an idea. For example, these are the some of the basically one sample t-test. So basically, for the one sample t-test, this is the effect size by default lah. So by default is meaning here, These are the by Cohen, where by Cohen is the from the previous published article where they come out with the effect size. At least, okay, these are the guideline by default you need to follow. If let's say if you could not find any previous study that you can come out with the effect size. Okay, for example, for the zero point 0.2, for the one sample test, 0.2 is the smallest effect size, with the medium 0.5 and the large effect size is 0. So from here you can see that the smallest the effect size, so the sample size will increase lah. So this will be for the one sample t-test lah. So now here, for example, suppose a previous study on the DMFT score of 12 years old reported by Ahmad is the mean DMFT score is 4 with the standard deviation 1.2. Now in your new study, you want to test whether the mean DMFT score among a similar population of 12 years old is significantly different from national average of 3.5. So thus, to calculate the required sample size for one sample to detect a significant difference between the sample mean DMFT score and the national average of 3.5 using the data from the previous study. So to calculate the effect size. So these are the some of the information that you need. You need to enter to the G power, for example. Now here, the tails here too. Okay, now the effect size that you need to calculate lah here from here. So with the alpha equal to 0.05 and power of the study 0.8 lah. So this is by cut-off point that at least you need 0.8 with the alpha equal to 0.05 lah. So now you need to enter the value, mean H0, mean H1. So these are the value that you get from the previous study, okay, as well with the national. And these are the standard deviation, and all the value that they enter, then you click calculate. So it will show you the effect size with the 0.41 something lah. Okay, so now let's say if you want to repeat for your study, so let's say I just reduce my effect size to 0.4, at least I can get to 50 total, the total sample size with 52 lah. Okay, so that will be for the one sample t-test lah. Okay, so at least you need to know from the previous lah, previous study, the information, then you need to calculate lah. Okay, so that will be, this is how you're going to report lah in your proposal. Let's say to determine the mean MT score, national average of 3.5, one sample t-test was used. The sample size was calculated using G power version 3.197 with the following parameter. As well, you may add as well with the screenshot with the G power lah. So with the effect size based on previous data with the mean compared to the national average. So with the alpha 0.05, 0 by the power of study 0.8 with the two tails. So based on this input, a minimum sample size of 52 participants is required to achieve the desired power and significant level. Okay, so that will be for the one sample t-test lah. So this one for the independent t-test, same as well. These are the sum of the effect size by convention 0.2, 0.5, 0.8. Okay, so with the allocation ratio, so these are the, if you want to have the same equal sample across the two groups lah. Okay, so as you can see, these are the effect size. From here you can see the lowest your effect size, the sample size will be the biggest lah. So as here, for example, here you can see the 0.2, at least you need 394 lah per group with the total 788 lah. Okay, so that will be for the independent sample t-test lah. Okay, so for example here, these are the sum of the from the previous study. So I need to have the mean and standard deviation as well with the sample. So these are the value that significant alpha 0.05 with the power of study 0.8. So allocation ratio sampling m equal to 1. So I want to have the equal across the two groups. Okay, so you just need to enter in the G power to in order to come out with the sample size lah. Okay, so basically dependent as well, same lah. So you might explore later. So I did give the example here. Same goes for the one way and as well. So whenever you just click by here determine, you just need to enter the value. Okay. So from the value itself, now after that, then you can compute the effect size for your study lah. Okay. So these are the some of the example. As I told you before this, the lower is the effect size, your sample size will be the bigger lah. So you need, in order to get the effect size, you need to come out with your from the previous study, you need to compute. So that will be your effect size that you can use, or you might reduce the effect size so you can accommodate for your study as well lah. So these are the last one, chi-square categorical. So the chi-square is that, as I told you previously, 2 by 2 lah. Okay, so basically you want to see association between the two group. So the chi-square test is used to determine whether there is a significant association between two categorical variables. Okay. However, when sample size are small, expected set count less than the chi-square exponent is unreliable. In such case, we use Fisher exact test, which calculate the exact probability of observing the data under the null hypothesis lah. So it's same as well with the two proportion previously that you're using P as power. You need to have the prevalence from the previous study. For example, here I want to compare prevalence smoking between urban and rural area in Pahang. So I have the prevalence for urban 0.12, with the rural 0.16. Okay. So with alpha 0.05 power of study. Okay. So I need to enter all the value into the G power with the two tails. So now the test family you need to select exact line with the proportion inequality to independent group Fisher exact test. So with the type power of analysis, a priori compute required sample size lah. So basically you need to select a priori compute required sample size lah in order to get the sample size lah. So for the proportion you have here, proportion for the P1 is a prevalence 0.12, the P2 0.16, with the alpha 0.05, as well as the power of study by default 80% 0.8, allocation ratio 1. So at least now per group you need 1,226 lah, with the total sample size with the 2,452. Okay, so that will be for the chi-square test lah. But now let's say if you want to do correlation, correlation basically is two variables. You want to see any correlation or not between the two variables. Select the exact correlation by varied by normal model. So now for the correlation, now here you might search from the previous study as well. So these are the some of the guideline here. Whenever you choose very lowest the correlation, you might need the higher sample size lah, as compared to 0.5. You just need very minimum 29 lah. Okay, so basically that is the for the correlation lah. Okay, so these are the some of the correlation as well. You can see later. Okay. As well, if you need, for example, simple linear regression, as I told you before, if you don't have by default value lah. multiple power that you might need to calculate lah. Also, for example, simple ini, I just need one independent variable, so that's why I put one. Let's say if you need two, you may put the two lah. Okay, so basically, whenever you put the effect size, the highest sample size, the highest effect size with the number of the predictor as well might increase, the sample size will increase as well lah. Okay, so the lowest your effect size, with the number of predictor as well, with the increase of the number of predictor, so you will increase your sample size as well lah. Okay, so basically this will be for the sample linear regression lah. Okay, so is there any question for this one? So there's also other tests as well, but this one I some of them will cover for PG. But again, it's okay for you. That will be enough. I mean, at least you get have that some of idea in order to come out with the sample size lah. So basic. Is there any question? No. Previously, some of you asked for the sample size. Is it you want to ask here? Maybe we can try one or two question here so that we can try to come out with your sample size. Is there any from you want to ask any question regarding sample size? Maybe for your study, you can show me the objective. We can try first. Is there any? Yes, no? You may put the comment in the chat box so that I can know. No, okay. How about this? If no, I believe that you have no question. So I conclude. So for example, so basically for the sample size, you need to come out the calculation for each objective. So usually you need to calculate based on each objective and then you choose the largest affordable sample size. For example, let's say for the first objective, you come out with the 50. For example, the second objective, 100. And the third objective, come out with the 150, for example. So you need to take the largest sample size to represent for your study lah. So when the optimal sample size is not possible to be taken because of the limited resources, so we might consider our study as a preliminary lah. Also, some of the preliminary study might useful in the study if then be done before. So basically, you can calculate based on based on the precision, power, detectable difference, backward with a possible sample size. For example, you might as well come out with the power of the study after you conducted, but better you estimate first lah. So that will be usual. You need to come out with your sample size. At least you know the rough sample size that you need for your study lah. So basically, these are some of the, how you come up with the sample size calculation lah. I hope you get an idea. I hope this will help you in order to calculate the sample size lah. I think that's all from me. Thank you so much. If you have any question, okay, you may ask me first here. Or no, I believe you already understand. And then if you think that you need to ask further, you can set appointment later lah. Okay. I think that's all from me. Thank you so much. See you. Bye.
Thank you,
Thank you so much.
Thank you, Doctor.
Welcome.
Thank you, Doctor. Thank you so much, Doctor.